Let me now introduce Agata Marciniak, who is a representative of Metroplan Poland. She is the project director and actively works on the implementation and development one of the largest simulation models in Poland. The title of her presentation is a simulation model of automatic warehouse installation in the Rossmann's distribution center in Łódź, why it's necessary. The original plan was for the model to be presented by Professor Konrad Lewczuk, but he was unable to appear today due to academic commitments. This is why even more credit goes to Agata Marciniak, who as a project director agreed to present it herself. She is the best person to provide you with a wealth of knowledge and insights related to this project. A great round of applause for Agata. The stage is yours.
Thank you very much. Good afternoon, ladies and gentlemen. Hope you all enjoyed your lunch. Today I'm going to talk to you about a simulation model of a specific facility, a warehouse distribution center based in Łódź, one of the largest distribution centers in Poland, as well as I think we can comfortably say Central and Eastern Europe altogether. As per the introduction, I'm a representative of Metroplan Polska company, just a couple of words about the company itself. We specialize in an end-to-end solutions for clients, taking into account consulting, production, architecture and logistics, predominantly warehouse architecture, logistics services, and as of 2020, roughly 2020, we also provide simulation models with the use of FlexSim solution. I myself have been with the company since 2018, if I remember correctly. It's been a while. Some of the very interesting projects which I had the chance to be involved in is, for example, a national hub for Daimler, which was executed back in 2020 in Alabama, in the US. I also helped out realize 2 automatic high bay warehouses, one of them based in Romania, with a frozen high bay warehouse for production of frozen bakery products, as well as one fairly local. You might be familiar with it, a project which has been realized in 2021 for Kolian, who's the leading manufacturer of drinks and sweets on the Polish market. We also have automated high bay solution there with a connection to production facility. So this is my experience so far with Metroplan, with I would say the largest execution so far. But what I'm going to talk to you today about is specifically the Rossmann project. In terms of a brief agenda, first I'll say a couple of words about the background of the project. Then we'll focus on the process and its challenges, the alignment of the simulation model with the needs of organizations, so how we actually had to tailor our works and our approach to make sure that we fit with the expectations of the organization itself. Key decisions which impacted our final product, and then we'll go over the installation mapping, maybe not in a very traditional way, because I understand that some of the presentations today were very technical and very detailed actually by the modelers themselves. What I will do today as a project director, not actually personally modeling the solution, is talk about how we've led to the final product, what we focused on, how we could have recognized customers' needs, and how it affected the end goal. And I will also talk to you about some key benefits of the model itself. And I will actually speak about real-life benefits. So something I already know, I have feedback from Rossmann that these are the 5 examples where they managed to use the simulation model already in the organization. Obviously, this is not the end. It's just a few examples which, as I said, I've been made familiar with by now. So starting off with the project background, as we can probably all agree, investment, development and research boosts economic growth, enhances services quality and helps out the expand in the market. And specifically, as we can see in the graph shown on the slide, in case of Rossmann, this has been very rapid growth since 2000. As you can see, the original number of stores back in 2000 was only 61. Whereas year 2024, we now have 1,842 drugstore locations. And I can assure you this is not where Rossmann stops. It's a continuously developing company. Taking into account such a huge growth over the last 24 years and the expansion plans, Rossmann has recognized that they need something more, something else rather than just traditional tools. Even if we take into account the tools and possibilities of the Industry 4.0, They also looked into simulation, what we can do, how we can do it to make sure that we use the best tools available on the market. Simulation, specifically with the use of FlexSim, has been recognized as one of the most competitive tools that they can integrate into their operations. So actually back in 2020 we started the first discussions with Rossmann. First it was more of a conversation based around, yes, we want simulation, yes, but what do you want from the simulation? What's going to happen next? Which software are we going to use? We were always strong advocates of the FlexSim tool, from our point being the standalone best quality available product on the market. And since 2020, we have started this relationship with Rossmann for the first simulation, which was started and also completed, handed over back in 2020. We have since managed to also introduce some updates to the simulation, which was developed back in 2020. And it's a tool that's constantly being used within the organization. We are actually really pleased about this relationship. We hope it's not, it's something that's going to develop over the next years, that's going to continue specifically in the scope of the simulation. Now let's talk about the facility itself. The facility is based in Łódź, and it boasts 66,000 square meters. And I think Rossmann is one of the best examples of how installation evolves around its user, its needs in terms of growth and in terms of the supply chain, what actually has to be developed in order to maintain the operations, as well as how we can look ahead to make sure that we identify the needs to come rather than acting in a very reactive manner rather than proactively. At the moment, the Rossmann facility manages around 24,000 SKUs with around 7,000 new items added annually. And the facility is working 24/7, needless to say. It's definitely one of the largest installations, and I think it's fair to say that it cannot be understood fully with very traditional analytical tools. As you can see from the table, the first expansion started in 2010. Apart from the Łódź facility, there's also two additional facilities, one based in Grudziądz, one based in Pyskowice. These are manual facilities, however, whereas in terms of the Łódź facility, it's a facility where we have a high level of automation already. In 2010, we had the creation of the first picking gallery for the capacity of 60,000 totes. Only a year later, we had development of the first high bay warehouse of the capacity of 7,300 pallet places. 7 years later, we have a huge development, because if you look at the scale of the investment from 2011 to 2018, we've got 7,300 against 42,500 pallet places, so it's a significant difference. In 2019, a shipping warehouse has been developed, which is serving 144 directions. That gives us around 8,350 containers. In 2020, we have the second picking gallery, and again, here you can see the trend, the first one being 60,000, the second one being 96,500 totes capacity, and the automated pallet installation being added to the entire solution in 2022. So you can see the amount of installations, the capacity of the installations themselves, and in order to gain this global perspective and enable any type of optimizations, what-if analysis, Rossmann as organization couldn't rely just on the knowledge of individuals, of people who are very specified in the field of expertise, who have huge knowledge, yet they only usually focus on certain part of the installation itself, not looking at the entire installation holistically. So the main goal from Rossmann's point of view is obviously making sure that we can allow for this global perspective and recognize possible optimizations and changes into the already existing installations. Just to look at the components of the installation and how we introduce them in the model itself. As you know from previous slides, we have 5 main installations, but actually the way we worked with FlexSim, we divided into 8 components. The first 2 are high bay warehouses. Both of those have their own monorail automated trolley systems. Then we have the 2 mini loads, one of the smaller capacity and one of the larger ones, which are called in short AKL1 and AKL2, where we have manual picking and pallet to container repacking activities. Then we have automated shuttle system for storing and sorting shipping containers, roll container formation installation, and in brackets is the PNG. PNG is actually short for a process which was the culprit of the name. In Polish, it's paper on top. And this is where we have application of lightweight products on top of the already assembled roll containers. Then we have number 7, which is the automatic warehouse for shipping units, managing roll containers and dollies. And this is nothing else than an automated dollitizer, which is preparing stacks of dollies ready to be shipped to stores. The process is mainly automatic in that the dollitizers are an automatic solution, whereas there are also manual steps to the process, such as application of labels, applications of seals, which has to be completed as the final step. However, we only focused and mainly focused on the automated processes, which weren't affected by, where the efficiency of the model wasn't affected by the manual part. And the final point is the mainframe conveyor system, which is a lovely name, Big Loop, and it certainly is a huge installation, and this is for large-scale internal transport operations. Now I will move on to the process and its challenges. And what we can see here is comprehensive warehouse process characteristics, as you can see, so receipt, repacking, storage, and so on. You would say that's fairly standard. But what we have to consider here and what we have to take into account is the scale of the operations. Not only scale of the operation itself, but also the variety of different systems which we're working with. So we start with the receipt of palletized materials and progress through various stages, storing the materials in pallet racks, specifically the manual type, which wasn't part of our simulation model. However, also in the highway warehouse, so this is where we have automated solution, then repacking materials into reserve containers and then storing them in reserve picking galleries also. The process continues with the execution of pick and pass orders in the 2 independent picking galleries. So we have automated installations, whereas the picking activities are pick by light, so the manual processes also. And these containers then get sorted, filled with bulk materials. And along the way we also have the repacking area where products are sorted, filled with bulk materials, buffered, and ready for dispatch. So the complexity here is obviously vast because of the sheer size of the installations, and what is of probably the highest priority, which cannot be ignored, is the interdependencies between the installations themselves and the numerous steps which have to be fulfilled in order to successfully complete a process. From the processes themselves, we've identified a few challenges. So because the basis for our work, for our approach was the multi-stage nature of the process and especially the predetermined time windows, the system was meticulously designed to operate with narrowly defined shipping time windows. We have very tight operational margins, and something that cannot, again, be ignored is the complex management of the system. So the entire warehouse management system, including the material flow computer and the integration of essentially 5 separate installations by 5 different suppliers, that alone is a huge process. There's also lots of external applications which Rossmann was forced to introduce in order to tie those processes, include all those handshake points, and make sure we have a continuous flow between different deliverables, however. Then we have the diverse, highly automated technologies, which is something I already mentioned, but also because we have such a disparity between installations, there's also lots of, for example, maintenance issues, which vary from area to area, and these also had to be included. Even though we worked with automated processes, there was lots of manual interruptions into the processes. The large-scale operation is obviously something I already spoke about, but all of those points, all of those challenges generated one outcome, and the outcome was we need something centralized. We need one central control tower. We need something that will allow us to have this global outlook onto the entire operation, and we need something that will ultimately allow us to have the what-if analysis, which so far has been very separated. So whereas we could look at one installation, Then, as soon as we moved closer to the handshake point between the installations and moving from one to another, there was always something missing. And this was the missing bit that Rossmann was hoping that the simulation can actually tie together. In terms of the decision, considering all the factors I mentioned on the previous slide, this is ultimately something that led Rossmann to collaborate with Metroplan Poland in developing the simulation model. As already mentioned, we've always encouraged Rossmann from the very early conversations back in 2020 to only consider working with FlexSim software. We just thought it's the best forward-thinking simulation standard that we can offer a company. As much as we've also worked in different projects, more development type of projects, in this case, with the scale of the operations, the complexity of the operations, we've recognized that this is a completely different and intriguing dimension to us, and the project itself has been tremendously rewarding, and hopefully it's not one of our last ones of this scale. Now I'll move on to the actual alignment of the simulation model with the needs of the organization. So what I would like to focus on here is the project work plan. Essentially, we've divided the project into 4 phases, phase A, B, C, and D. Phase A can also be called the appraisal phase, let's say, because the first and most important from our point of view step, which was crucial to determine how we're going to work with Rossmann and with the development, with the modeling activities, was the needs analysis of Rossmann and the requirements of the organization and technical capabilities of FlexSim to make sure we have a tying point between the technical aspects, the operational aspects, and also what are you as an organization going to do with the model? How are you going to use it? Which departments? For what purposes? And where does it take us? So this was the first step, which was more based around discussions, Teams meetings, on-site meetings, just to brainstorm around what is the plan for the future years to come with how they're going to work with the model. Then the second point, which is a consequence of point number 1, was on-site visits and actually spending lots of hours walking around the warehouse. The first was just, let's forget the tool, let's forget computers, let's take a site walk, let's walk through each single installation, let's have lots of people, meetings on site with the maintenance personnel, with the operational personnel, with different departments. Let's gather this information. What are the biggest issues currently? What are you struggling with the most? And only then, once we've scaled the size of the installations, we were then able to compare it with the technical capacities and capabilities of FlexSim. And this is also something that led us to make the decision of how we can proceed with the modeling works. We then, shortly after, we made the decision to have 3 different models, so to make the model fragmentation, because we knew that the amount of detail behind the installations, if we even attempted to make it one large model, as you can already see from the size of installations, it would simply be unusable by the client. So we made sure that we communicate it and we guide the client as to how we can incorporate all the details to make sure it's still a usable tool that they can utilize on a day-to-day basis. Point number 5 is development of 3D layouts. I know we already spoke about 3D layouts beforehand today in some presentations, but essentially in our case, this was purely based on gathering all the information. So gathering all the CAD drawings, the 3D DWGs, making sure we have no gaps, making sure we've got all the specific layouts handed over by different suppliers of automation. Making sure we have everything, it's complete, it's uploadable, it's not too heavy, it's something that's not going to affect the model itself, and essentially will allow us to proceed with the works. And then the final point was, as already mentioned, it was the decision to simplify the data according to the model parameters established previously. From the initial phase, from phase A, we moved on to phase B. And if you think that phase A sounded intense, I can assure you that phase B is even more intense. Because if you look at the first few points where we've got the mapping activities, so whether it's process structures, transportation, material flows, or process, these are the sort of activities which at some point actually forced us to go a few steps back before we can move forward. And it was very much something that we tried to where we already thought we achieved agreement on the processes specifically, because what you must remember at this point is that we relied on individuals' knowledge. There wasn't a book where we would just take it and move the processes from a script or a book or internal procedures and move it into FlexSim. It's something that we had to interview almost. And also, as you can imagine, if you speak to different individuals, believe it or not, they had different approach to different processes. And very often we ended up in hourly discussions about one specific decision point. One would say it goes left, the other one would say it goes right. Where does it go, actually? So this is where we thought we implemented something based on knowledge that was handed over to us by a specific individual, whereas on the next meeting, next workshop, we found out this is wrong, we have to redo it. So there was few instances, but actually the positive outcome of this is that for Rossmann as an organization, also it allowed to create process logic map, something that they didn't have before. So there's also an added benefit, a win-win, almost as you could say, in developing an integrated process map, essential for us, and obviously highly beneficial to Rossmann, the chance to review their own processes. It also promoted internal discussions, so there's also other human aspects and more softer aspects to the process that happened along the way. During the control mechanism development, we focused on what can and cannot be delivered in terms of, again, the capabilities and a graphical user interface to control the model. And point number 7 purely focuses on the model testing and debugging and verification with the team on site. For the 2 final phases where we have the application phase and go-live phase, the challenge was mainly configuring the GUI to process and utilize real data which was already pre-processed. So we worked on something that was already given to us. This is where we also tested the first what-if analysis successfully. And in terms of visualization, we focused on real-time tracking and identification of bottlenecks already at this stage. And because we've done so much in terms of analysis of the data, workshops, meetings, clarifications, actually the go-live phase was just a formality in that our main focus was actually on the human aspect, on empowering the Rossmann team to work with the tool, to make sure they're trained to the correct level, that they can fully manage what they have received as a tool. We have, of course, developed also some training manuals as to how to use this specific simulation. I know for a fact that they had some training with InterMarium in the meantime. There was a designated team from Rossmann. I know that since 2020, since the original project, the team has definitely grown. And as I said, it's something that that is currently working. It's a live tool, and it's very comprehensive. And thanks to the training and operating manual, which was produced by us, it's also possible for them to pass the knowledge on. So there's like a key user who's responsible now for making sure that if there are any new designated members of staff that need to familiarize themselves with the model, they are there to, it's there to be had, it's there to be analyzed. In terms of the key decisions regarding the model, as I already mentioned, one of the key decisions was actually the model fragmentation. We decided to go ahead with 3 smaller submodels. One of the challenges which also had to be considered and couldn't be ignored is the equipment, is the office computers. It's something that was already available at Rossmann. And probably no organization, maybe it's not that it's not ready, but it perhaps doesn't necessarily want to immediately invest in a huge overhaul of the equipment that's available. Therefore, we had to take into account what capacities and capabilities they have currently and whether or not the models can be actually utilized with this equipment. And the strategic partitioning maintained the model's desired level of detail, whilst we also managed to ensure the computation manageability of the computers themselves. And the 3 models were actually planned and grouped according to the fundamental functional dependencies and material flows in the organization. So as you can see, in the top left-hand corner, we've got the AKL2 with the high bay warehouse, the large high bay warehouse and a large and a big loop. Then at the bottom, we have the repacking area we've got another picking gallery and the smaller hyper warehouse. And the final third model is the shuttle with the P&G installation and the dispatch warehouse. And actually this was the level of fragmentation and something that has been discussed again with Rossmann. We had the full support from them. We ensured that there's sufficient communication between the models, exchange tables and so on. So we knew that there is connection between the three models and it's highly operational from their perspective also. In terms of the further decisions which were made along the way, we agreed that the accuracy of representation will be the depiction at the basic material group level. Of course, we can have different approaches depending on what we're actually trying to create. If we're looking at very early preliminary conceptual works, obviously the level of detail is not going to be so high. In terms of the installation, working installation, which is already operational, unstoppable really at this point, we have to make sure that we try to depict what's already there. So what we ended up with is we went with material groups in individual installations with the granularity of one pallet and one tote, which then allowed for the team to gave it the flexibility to generate system loads. The system was tested over, was scheduled to be tested over a 24-hour period to mirror the actual operational pattern of the center itself. And in terms of the GUI, the model management, parameterization tables and dashboards with key results were also agreed and approved based on the expectations from Rossmann. In terms of the key expectations, because what we should look at towards nearly the handover of the ready tool is, have we actually fulfilled the key expectations of Rossmann? And originally we had those expectations grouped into three. Later on, I also decided to add the fourth point, which is the continuous improvement. So as much as the first three aspects focus more on the hard factors, on either financial analysis, profit and loss, or various what-if analysis, then the fourth one, the continuous improvement, focuses around the softer skills. And in terms of design and process, we had three main points to fulfill. Was the preparation of data for future investment based on the data available in the model already. So what can we plan? How can we plan based on what we already have, and where should we, which direction we should be going? Then we had the checking of the loads of key installation elements, and essentially testing the evaluating the technical solutions, both for existing solutions as well as the potential future solutions once these have been identified. In terms of optimizations, we obviously look at the number one of optimization. So the first step is always identifying the bottlenecks, then testing of potential optimization solutions, as well as the individual element loads. So obviously, as you can see, these are crossing over from the design to optimizations and made it even to the management part. As for the organization and management, we were focusing to prepare configuration data for modifications in the organization. So basically, profit vs cost, scenario analysis, as well as adaptation of the model to changes that were happening in the process. As for the continuous improvement part, what we've identified, which isn't so much focused on the operation of the installations, was the human aspect. And I think one of the teams has already mentioned something that they use in the training, in the HSE approach. What Rossmann has identified is actually that both for existing employees and for future employees, a simulation model is a lovely tool which can be used to speed up the training process, either for induction of new employees or for brainstorming ideas of existing employees, as well as actually having the holistic approach to the entire installation. So I can assure you that once you manage to visit, if you ever manage to visit the distribution center in Łódź, it's very, very hard, even if you know the layouts, you know the technical aspects of the installation, it's terribly hard to imagine the scale of it itself. So it really does help to have the simulation model to be able to look what goes from where, which way, and what does it mean to me, which system ends with one supplier, where does it start with another supplier. So it's a great visualization tool for the existing stuff as well as for new stuff. And obviously, third point is what I already touched on, the constant verification of procedures, of various ideas that employees might have It's something that doesn't actually have to be conducted in the warehouse. Obviously, it should and it could, but it's also good to bounce it off the simulation because this is essentially what it's meant for. As for the installation mapping and key benefits of the digital shadow, right now you will be able to see what we call a flight over the installation. And as you can see, we've got 5 systems connected into one. This gives you the scale of the project. Whereas mainly looking at simply the blocks, which you could see from the bird's eye view from the first few slides, this is where you're actually looking. This is, for example, the picking gallery before you've seen the repacking area. This gives you the scale of what we're dealing with. And I think whilst you're looking at the movie, what I will try to give you a breakdown of is what I mentioned at the beginning, which is the key benefits for the organization which have already been carried out. So again, going back a few slides, I spoke about the expectations, and they were to do with design, with process, with optimizations, and with the continuous improvement. So I'll have a couple of examples for both. In terms of the design, as soon as the simulation has been handed over, the team decided to carry out a simulation of the newly delivered mini-load installation in Łódź, and doing it before the go live. So this is what is important, because they have already managed to find, just by simulating it, even though it was a new installation, planned, checked by the supplier, also simulated for the results by supplier, they have already at this stage managed to find some optimizations of the system. And where it is important, because you could think they can do it anytime, right? They could, but what you have to bear in mind is where we have 24/7 operation, where we have such huge capacities to fulfill, any stoppages and trial and error of the working installation is a no-go. You want to be sure that what you're doing once you decide to stop the installation is actually going to work, or at least it has at least 90% chances of being successful. So this is where they already found some optimizations. So the go live was based on the improved processes rather than designed processes. The second example here is the simulation of a new process for picking of bulky items in order to assess the correct development path of a new installation. In terms of process, there's also one example where Rossmann has managed to carry out analysis of the efficiency of key elements of existing installations, using the shuttle before deciding to expand the mini-load. So again, it's something they wouldn't have been able to do without the simulation model itself. And as for the optimization aspect, there was also a couple of points, one of them being the shortening of the travel time of the stacker cranes in high bay warehouse. And it's something that, from my point of view, it's a significant number, because we're talking about 13%. And this has been purely achieved by changing the waiting time for the next handling unit for the stacker crane. So sounds like a very simple process. But again, if we did that in a live environment, first of all, we would have had to think and look at the stoppages of the system or potential delays of the fulfillment of the process. And the final one, which I wanted to talk to you about, is the improvement of the flow of totes by picking optimal waiting time at the handover point. So again, a process very much focused about trial and error, but a trial and error in the simulation model rather than in the live installation on site. So I think this gives off, if we're trying to answer the question, why is it necessary? Well, there's actual examples from real life, from the operations, why is it necessary? There's, of course, lots of different activities happening on a daily basis. The simulation is being used by different departments. There's logistics, there's planning, there's dispatch. Even maintenance teams use the simulation model to identify some potential problems and where they have to focus certain efforts. The model itself can be viewed at our booth in the foyer. So I strongly encourage you to have a visual tour of the model and maybe focus on specific elements of it if you wish. My colleagues and I will be there. We're happy to present it to you. As for today, from my side, that is everything. On the next slide, I only have a summary of those 3 benefits and how the simulation had been used by the organization. So if you have any questions, we will be happy to discuss this with you at the booth. If there's any questions now, of course, I'm also happy to answer them. And other than that, thank you very much for your attention, and I hope to see you all tonight.
Yeah, thank you, Agata. So this is a perfect time to ask some questions if you want. So please raise your hand, and yeah, there is one question.
You say that you have the struggle with two individuals have
different approaches.
Different approaches. And like I think everybody who works in production have that experience. So did you fully automated, yeah, the information gathering?
Well, actually, it was an interactive process. So we were still we still had a series of workshops planned. So the way we achieved conclusion, because I think this is what you're probably trying to get. So who was right, essentially?
Yeah.
So first of all, it was, what we ended up doing is involving different team members. So whereas we try to work in smaller teams to make the process more efficient, wherever we found that we are hitting a dead end, we would involve other team members. In some cases, it was so much so that we would have 2-to-1. So two individuals think it's this way, and one individual thinks it's something different. And essentially, it was also inspection on site. So we had this opportunity and this luck, because we actually have a live installation. We can go to the warehouse and we can revisit, and we can stand there for even 50 minutes with a timer. We can measure, we can check what is the actual process. Sometimes it was also involvement of IT. So where we had especially decision points where warehouse management system, MFC, was involved, this is where we look to make sure, well, hang on, we've got two operational guys which are convinced they're right. What does IT say? Because essentially they're steering the system, right? So they can't be wrong. So this was usually how we managed to achieve the conclusion. And once the decision has been made, we just made sure we note it properly, we make sure we have minutes of the decision, and then integrate it into the manuals later on.
Okay.
Any of you want to ask Agata for something now? Yeah, there is one more question.
How much time did the project take? The whole project, from the first speaking to the result?
So the first project appraisal conversations happened around June, and we were handing over in November. So we're talking roughly 6 months. And then obviously we had the hypercare period, whereby we had lots of meetings, still clarifications on not so much how FlexSim works, because this wasn't the scope of delivery, but the scope of delivery was certainly clarification of certain logics, which may have not been clear, especially as FlexSim at that point was very new to the organization. The individual who was back then appointed as the, let's say, manager, the key user of the simulation tool, was also undergoing training. So that's why we said we will proactively help out the organization to actually work with a model to make sure that they can have the benefits immediately almost. So yeah, I think it was end-to-end. We're looking roughly 6 months with roughly 3 weeks after the handover until final approval of the model. So I think we're looking end of 2020, which would give us overall, with the finished signed off protocols, around 7 months.
Oh, okay, I'm impressed.
Thank you.
So for me, this project make a huge impression too. So
thank you very much.
Thank you, Agata, for sharing this knowledge.
Thank you.
And make a great applause again for Agata.
Thank you very much.